Okay, good morning, welcome back. Happy Friday. Our quick look at the calendar shows us that the semester is winding down. Today is our second of 3 days on algebraic fractions, although really there's 4 days on algebraic fractions because this one here is equations involving algebraic fractions. So this is day 2 of 4 basically for the remaining material. We'll finish the new material for the whole course on December the 10th, which is Wednesday coming up. Wednesday will be our last day of new material. There will still be almost a week left in the semester. Friday, 1 week from today, is our 5th and final quest. It will only cover the new stuff, the algebraic fractions, since the test that we just took. All right, so the quest is just on all the fraction stuff we're doing. Then on the 15th, which is Wednesday, the last day of the semester, it's our review day for the final. And then the final exam is coming up on December 17th. I think I might have said the 15th was a Wednesday, but that's a Monday. And then the 17th is our final. Any questions on the calendar? Wednesday, a little less than 2 weeks from today. Okay, so in terms of prepping for the quest and the final, there are sample quest problems in the packet a few pages from where we are now. You'll find them if you just look a little bit. And then I just handed out today some practice problems for the final exam. These are from you're welcome. These are from my colleague Peter, so I will thank him on your behalf. There are answers at the back of this packet of practice problems, but there are no videos for these problems. If you have a question about something and you can't get it resolved with the answer key, ask me, ask somebody in the studio, ask one of your colleagues in the class, okay? I don't have videos for these. Okay, and the other thing is, so probably you're not really thinking about studying for the quest yet, but you should be thinking about studying for the final. It is on everything for the entire semester, and waiting until the day or two before the final exam to start studying for this cumulative exam is a bad idea. So maybe you can kind of make a routine, a plan that says just every day between now and the exam, you're going to study like 20 minutes. I'm not talking like 3 hours a day, but like just dedicate 20 minutes a day. And if you're consistent about it for almost 2 weeks, that's a good chunk of time, and it's a lot better strategy than waiting until the last minute. All right, so on page 79, we'll start up here at the top. Can we go to Dan? Megan, number 1. Okay, so here's an example. And just to refresh our memories, last class we talked about taking algebraic fractions and simplifying them. And we also talked about multiplying and dividing them. Today we'll talk about addition and subtraction, which surprisingly is harder than multiplying and dividing. So 2/5 plus 2/3 plus 5/3. We know the answer is 7/3, but let's just go a tiny bit slower. Why is it 7/3? What happens to the 2 and the 5? You add them, and so I'm just gonna, like, nobody would write that, but I just want to be clear, that is what we're doing, but it's just so quick for us that we say, oh, it's just 7/3. And then what about the denominator? It stays the same, right? We're not adding down there. Same denominator, you just add on the top and you copy the bottom, which is fundamentally different than multiplying fractions where you go straight across on both top and bottom, right? So we got to recognize that we're doing something different on the top and the bottom. And then of course our answer is 7/3. Let's go to Mary for 2. Okay, so we've got 9x squared minus 1x over 3x plus 4 minus some other stuff over 3x plus 4. This is a subtraction problem. When you're subtracting fractions, you need a common denominator. Do we have a common denominator? Yes, so we're really happy, and we treat this one exactly like we did the numerical example above. So I'm going to first deal with the denominator. What is the new denominator? 3x plus 4, right? You guys know that you don't do anything to that denominator when you add the fractions. It's the common denominator. Now I'm going to go slow, just like we did this guy up here, the numerical one, slow. I'm going to copy the first numerator, 9x squared minus 1x. And then I'm going to copy the other numerator. What goes in between? Minus, right, because it's a subtraction. 3x squared minus 9x. We do. We're going to get this wrong if we carry on. And it's a subtle difference, but it's really easy to write what I wrote, but we've made a mistake here. The idea is that we are taking this fraction right here, that whole thing, and we are subtracting this fraction. And so imagine that highlighted blue thing is just one entity. It's just all in a bag, and you're subtracting the entire bag. But the way that I've written it up here in blue, am I subtracting this entire bag? No, I'm just subtracting the 3x squared. But I'm not subtracting that negative 9x. So we do need parentheses right there. And just so the front guy doesn't feel left out of the party, let's put parentheses around him too. I mean, that one didn't matter, but there's no problem putting parentheses everywhere, but there is a problem with not putting enough parentheses. So better too many than too few. Okay. How do I deal with the first parentheses? Well, I didn't really need them in the first place, so I'm just going to copy that first guy without any parentheses. But now the second parentheses is the one where things change. What does it become? Minus 3x squared and then plus 9x. Copy that denominator. Okay, and now we're going to combine like terms. So 9x squared minus 3x squared leaves me with 6x squared minus 1x plus 9x plus 8x. Okay, can I cancel? Like we should always simplify if we can. So for example, can I cancel like the 8 and the 4? No. All right. What about canceling that x and that x? No. 6 and 3? Nope. You guys are a tough crowd. Why can't we cancel anything? It's not multiplication, right? The only way we can cancel is if we have multiplication everywhere. So we do need to take a moment to try to turn things into multiplication. And in this case, we can do something on the top. So let's do it. What can we factor out of both terms on the top? A 2 and an x. So let's pull out that 2x. And so let's say 2x times something is 6x squared. I guess that's 3x. And then plus 4. Okay. And then on the bottom, can I do any factoring? No, it can't do anything with 3x plus 4. So we'll just copy that. But then at that moment, we recognize, hey, we actually can simplify this thing. So the 3x plus 4's cancel. And so our final answer is just plain 2x. Okay, any questions on that one? Okay, so just 2 notes of caution, just highlighting stuff we said before. Put parentheses when you merge the 2 fractions into 1. And then make sure you do spend a moment trying to simplify at the end, which means factoring first and then seeing if something cancels like it did here. Okay, number 3, let's go to Nick. Okay, so we're going to again start with a numerical example. We can't do the numerical one. We have no hope at doing the thing with x's in it. So let's make sure we're solid on the numerical one. So 9/28 plus 3/20. Why is this harder than the first numerical one? No common denominator, right? Different denominators. So we need to build a common denominator. Now, one thing you could do, just as a rule of thumb, anytime you want a common denominator, what can I do with the 28 and the 20 to just build the easiest common denominator possible? You can multiply them, right? 28 times 20 is a common denominator, right? And it will work. But the fact is, it'll make the numbers maybe a lot bigger than they need to be. And if we don't have a calculator, it would be kind of annoying to do 28 times 20. Also, I think we need to do 28 times 3 and 20 times 9, have these big numbers floating around, which eventually we'd have to simplify to smaller things. So how about better than that? We start with the lowest common denominator. Now for 28 and 20, it's not obvious to me. Sometimes I can just look at the denominators and it's really clear to me what the lowest common denominator is, around 79. But it's not obvious to me what the denominator is here for 28 and 20. So we're going to do something that's going to be helpful in this next example, which looks quite complicated. We're going to factor those denominators completely. So 28, we're going to factor it. What times what? 7 times 4, yeah. 7 is what kind of a number, which means you can't factor any farther? It's prime. 4, we can factor farther, is 2 times 2. And so I'm going to write that as 2 squared times 7. Agree? That's the same as the 28. And this is something that you did way back in, I don't know, like 4th grade or something, right? There was some place where you just started taking these numbers, these new building blocks, and writing them all. Never did 2 squared? Not as a 4th grader? No. Yeah, you could write 2 times 2 times 7, but I'm going to write the squared up there. I think it's going to help us. I'll copy the numerator. There's no need to factor the 9. It's the denominator that we're trying to figure out. Plus 3 over. So same idea now. We're going to take the 20 and we're going to factor it. So you can just write 4. And in fact, I'm not thrilled that I picked this example. So I'm going to tweak this example right now to show you why I wanted to do it this way. Let's make this, instead of 20, let's make it 40. Let's do that. Can you guys just update that denominator? Okay, so now we're going to factor that denominator. Yeah, the whole problem is now changed. It's just a 40, not a 20. Okay, so what are the factors of 40? So 2 squared and another 2 and a 5, right? 2 times 2 times 2 times 5. Yes, that's 40. Okay, so we're going to write that as 2 to the 3rd times 5. Okay, and now the goal is to build the common denominator. First, figure out what that common denominator is. Okay, definitely looking at this first fraction, I need a 2 squared and I need a 7 in my common denominator. And then we're going to kind of keep building on that partial common denominator. I see a 2 cubed over here. Do I have 2 cubed already in my common denominator? No. What am I missing? Is a single 2, right? I just need one more 2 in order to turn that 2 squared into a 2 cubed. Do I have a 5 already in my denominator? No. So I think I've got my common denominator here. I need a 2 cubed and a 7 and a 5. So you have 2 squared. We do. We're going to use the 2 squareds, but we need a little bit more than that. So I think what we figured out is that the LCD is 2 cubed times 5 times 7. It's basically one copy of everything that you see. You don't need to put duplicates in. So, you know, there's 2 2s in the first guy and 3 2s in the second guy. I don't need 5 2s altogether. I just need the most 2s that I see. I need something that everything goes into. Okay, and so now we're going to do this idea of, I wrote the word up here, missing. We're going to fill in what's missing in the denominators. So let's look at this denominator right here. I have 2 squared and I have 7. I'm trying to build 2 cubed and 5 and 7. What is it missing? A 2 and a 5. So I'm going to multiply down here by 2 and by 5. But if I do that, I've unbalanced the scales. What do I need to do right away to pay for it? So upstairs, 2 times 5. And then we'll look at the other fraction. I have 2 cubed and 5. What is it missing? It's just missing the 7. So times 7 there, times 7 there. Now take a look at our denominators. 2 squared, 7, 2, and 5. What is that really that's equal to? Mushing those 2's together is, it's this guy, right? It's this LCD, 2 cubed times 5 times 7. How about the other denominator? It's exactly 2 cubed times 5 times 7. We have a common denominator, and in fact, we have the smallest one, least one. Okay, so let's proceed. Upstairs, we just need to do the multiplication. 9 times 2 times 5 is 90. Divided by the LCD. So I guess at this point we can actually calculate the LCD. How much is 2 cubed times 5 times 7? 7, so it's 740. What is it? 40, oh yeah, 280. Thank you. Plus, okay, and then the other fraction has a 21 upstairs, and downstairs is the same 2 cubed times 5 times 7, so that's still 280. And so altogether, upstairs 111, downstairs 280. And as usual, we still have to simplify if we can. Now, there aren't that many numbers that go into 111. Does anybody happen to know a number that goes into 111? So 11 looks like it goes in, but I don't think it does, because 11 times 10 is 110. So close. 3 goes in. Yeah, there's a nifty little trick to know if a number is divisible by 3. Do you guys know this? If you add the digits and whatever you get is divisible by 3, then so is the original number. So if you add 1 and 1 and 1, you get 3, which is divisible by 3. So that guy is also divisible by 3. Yeah, any number that if you add the digits, if it's divisible by 3, then so is the original. And the same is true for 9. Okay, but in any event, there's no 3. So 280 is not divisible by 3 because when I add the digits, I get 10, which is not divisible by 3. So I don't think we can simplify any farther. So that one's good. Now we're going to move on to the tough one, which means that was the easy one, just for perspective. So let's try B here. So I'm going to be adding these 3 things together. What's that? Adding and subtracting. Thank you. Okay, the first step is the same as what Nick read to us a few moments ago. Factored the denominators completely, just like we took 28 and 40 and factored them in order to uncover what the LCD was. So we are going to factor these denominators. So this guy equals, all right, I'll copy the top, that's a 3x. Downstairs, what can I factor out of both terms? X. So X comes out, and then we're left with some stuff in the parentheses. X plus 4. Okay, so I think that's good for the first fraction. Now I've made my fraction line longer than it needs to be in preparation for putting some missing stuff in there. Minus. Okay, upstairs, 5x minus 1. Downstairs is one of our old product sum examples. Right? You could use the box if you wanted, but you don't need to. Yeah, so we need a product of negative 12 and a sum of 1. Yeah, so I think a plus 4 and a minus 3 will do it. Okay, and I'm going to leave a little bit of space on that guy too. And then plus 6. Now 6 is really just 6 over 1. And there's nothing to do with that. I've just made it a fraction. And now we're going to play the game with the fill in what's missing. Okay, so let's look at this first denominator. I see an x and I see an x plus 4. Great. Looking at the next denominator, I see another x plus 4. Okay, there's some overlap there. Then I see an x minus 3. Does that first guy have an x minus 3? It doesn't, so it needs it. So let's give this first guy an x minus 3. But at exactly the same moment, what do? Top x minus 3. Okay, yeah, so I think that this first guy is complete right now. If you look at the rest of the denominators, this first guy has everything and then a little bit more. So let's look at the second denominator. It's an x plus 4 and an x minus 3. What is it missing from the first guy? Is that x. So let's give this guy an x, which means also upstairs an x. This looks really funny to me upstairs the way I've written it. What should I put in to make really clear what's happening? Yeah, there's a times and also parentheses, right? That was the whole bag, that numerator was the whole bag, and it is getting multiplied entirely by x. Okay, what do we notice about those two denominators now? They're the same, wonderful. This last denominator is a 1. It's missing everything. So let's give it everything. Alex? Okay, so it gets an x and an x plus 4 and an x minus 3. And then at that same instant, upstairs, all the stuff. And just to be consistent, I'll throw parentheses around the 6, just like I threw parentheses around the 5x minus 1. Maybe we'll... That's right. We've got the LCD in all these denominators. And this one, I didn't know ahead of time what the LCD was going to be. I just kind of built it by filling in what was missing, by completing the denominators. So eventually they all matched each other. Okay, so this is good. Now I've got the same denominator. So that means I can make one big fraction. And what will the denominator be? All that stuff, right? X plus 4, x minus 3. Do I need 3 copies of that? No, just a single copy because they have the same denominator. All right, and now I'm just going to be copying everything that I had upstairs, but now they're all on one fraction. So 3x, x minus 3. What's the next symbol? Minus, because we're subtracting. 5x minus 1 times x. And then plus. Uh-oh. Plus 6x, x plus 4, x minus 3. Okay, now there's one really common error that folks make at this moment, and it's to say, okay, downstairs is multiplication, upstairs multiplication, so x minus 3 cancels x minus 3. Yes or no? Why not? There's still addition and subtraction upstairs. The bottom is multiplication. The bottom x plus 3 or x minus 3 is ready to be canceled, but the top is not because there's a fundamental subtraction and a fundamental addition. And in fact, if you cancel the x minus 3s, all you are doing is getting rid of the hard work that we did to build the common denominator, right? So you put it in there, don't cancel it right away. Okay, so what we need to do now is distribute on the top. We've got lots of parentheses here. I'm going to do this quick. You can check the answers later on, but we'll distribute 3x squared minus 9x minus, then this x comes in here, 5x squared minus x plus. Okay, this one's a little bit tougher. I'm going to do it in 2 steps. I'm going to distribute the x plus 4 and x minus 3 first, and the 6x at the end. So that's x squared plus x minus 12. And then I'm going to get lazy and allow you to get lazy. If the common denominator is kind of big, it's okay to just write LCD. Like I trust that I don't need you to just keep copying that denominator. So that's okay. But I have made a mistake up here. Same mistake I made earlier in this class. Yeah, I think that part's okay. If we keep going the way it's written, we'll get the wrong answer. Yeah, it's this minus sign right here, which I copied right down there, which is okay, but I've lost sight of the fact that this was one bag of stuff being subtracted, and I didn't incorporate it here. So it's still in the bag until I have subtracted the entire thing. It's going to become a plus x. Okay, so here we go, equals. So now we're copying this guy. We'll distribute that minus sign throughout, minus 5x squared plus x, and then we'll distribute the 6x. Okay, we'll now combine like terms upstairs. So I like having my highest power first. So what's the highest power anywhere upstairs? Is that 6x cubed? Does it combine with any other term? No, so there's no other x cubed. So the first thing I'm going to write is this 6x cubed. And then because there's so much to keep track of here, again, I like putting little check marks just to tell me that I've dealt with that guy already. Yeah, so let's look at some x squared terms. 3 of them there, minus 5 of them there, plus 6 of them there. I heard a vote for 4x squared, is that right? Okay, so that's a plus 4x squared. And then finally the x terms, minus 9, plus x, minus 72. Is that minus 80? Yeah, there's that plus x in the middle there. Is that right? Minus 80x. I warned you this was going to be tough, right? Yes, Sam.
Then when we get here, don't we have to distribute
So yeah, we do have a tiny bit more to do. This one's almost done, but I don't want us to distribute downstairs, at least not yet. What I want us to do is recognize that is the top in a cancelable state right now? No, because it's addition and subtraction. So we're going to factor. What can we factor out of all that? A 2 and also an x, right? So we're going to factor that 2x out of the top. Okay, and if we can cancel, if we can factor inside of those parentheses, then we kind of have to do that. Is that one of the easy product sums or one of the hard boxes? It's a box one. So here's what I would do. This is not something you need to do, but what I would do if I were faced with something like that, which I have a hard time like seeing whether or not it factors. So you can do the box method, but it might not factor when all is said and done. So you guys remember this calculation that we did a few weeks back? It's called the discriminant. And so I do this calculation because it's pretty quick. So if I do my b squared, that's a 2 squared minus 4 times 3 times negative 40. So that's 4 minus minus makes plus. And I think that's 480. And so altogether, that's a 484. What does that tell me? So this guy inside of the quadratic formula lives under a square root, right? And so depending on whether 484 is a nice thing to have under the square root completely dictates whether this guy factors. So the question is is 484 a perfect square? The answer is yes. And because it's a perfect square, it's going to have those nice solutions. And I was looking up here a moment ago. 484 is 22 squared. It's just off our charts here. So that means this guy actually does factor. I'm so mean to put this in the, it was already hard enough, but apparently that guy factors, so we need to factor it. Let's throw some parentheses here. I'm just going to try a quick trial and error instead of going through the box method. Definitely going to be a 3x and an x. And say it again. Wait, I have a 3x and an x. That's a +4 and a... Okay, Dan says that. Now, I don't know how Dan came up with that, but if he comes up with it, we can check whether or not he's right by doing the outers and the inners. What do we get when we multiply the outers? Is it +12x? Inners? -10x? 12x minus 10x is the 2x that we wanted right in the middle. So that is exactly the right factorization. So with the box and a little bit of time, which we didn't spend, hopefully we can get that. And now finally, I'm going to stop writing LCD, but I'm actually going to write explicitly what it was. But it's way off the screen for me, so can somebody remind me what it was? Okay, so the very, very last step here is to do what? Cancel, right? If you have a common factor on the top and the bottom, you cancel. And so this guy cancels. So then our final answer, 2x, 3x minus 10 over xx minus 3. Oh, wait. What else cancels? X cancels. That x and that x. That goes away. That goes away. So then I think we have an even simpler answer, 3x minus 10 over x minus 3.
No, we canceled the x.
You cancel the x, so the 2 is still there. Okay. So a couple of notes about this one. First of all, it's as hard as it gets, and I intentionally chose to put something that is as hard or harder than any of the ones in the activity or homework, just because, hey, if we could do this toughest one, then you can do anything. So this isn't like a building block to something more complex. Another important thing that's going on here is that when I wrote down the LCD repeatedly, what did I never do to that thing? I never distributed, which was quite strange because we spent a lot of time distributing up here, right? That was what we did there, and then we had even more distributing to do. So we distributed like crazy up on top, and we didn't distribute a single time on the bottom. And it's important to make that distinction because by not distributing downstairs, we had it in that form from the beginning, right? And that's a great form because it means you can cancel, right? So don't ever distribute on the bottom, because if you do, you'd have to just factor it back anyway to see if something cancels. So the reason we distribute on top is because we've got subtraction and addition, and we're going to have some terms combining. But there's no sense in ever distributing down in the bottom. We just leave it as it is, which is always going to be in factored form, and then things will be cancelable. Sam?
What about after you canceled everything out, then you distribute it into the final form, so you'd have like 6x minus 20 over.
So you're completely welcome to distribute after 6x minus 20. In some sense, and this isn't something that we'll see this semester, it's actually better to leave things in factored form anyway, but if you feel like you need to distribute, you can. Yeah, but you don't need to at the end. Okay, so activity is on the next page. Raise a flag if I can help.